And let's just start with the basic structure for the buffer. Or I will just explain the basic steps we will be following in our buffer overflow practicals today.
What
So
is today? What is today the lesson? What is?
today we will focus on a critical vulnerability for the softwares.
Okay.
I'll explain a critical vulnerability for the software that was your buffer overflow.
Buffer overflow.
Overflow.
Mm.
So let's just start with what is buffer overflow first thing, right? And for that, I need to draw some diagrams out there.
It's
Just
like flooding.
it's like flooding, you can say.
Yeah, sync flood and like this. This is what we can see in the my firewall sometime.
No, that's a different thing. That's a different thing. But it's kind of the flooding. It's kind
Yeah.
of the flooding. It's still the same thing.
Yes.
It's somewhat you can relate it with the basic flooding. It's somewhat similar to that critical flooding. But in normal buffer overflow part, you simply flood the memory in your CPU, right? In our CPU, whenever you execute a program, let's say you are executing a software, right, which will asking you for the username and password. Your software asks you for the username and password. It means you have two variables. First one for your username, second one for your password, right? And whenever we develop a software, we specify the maximum size that a variable can carry. We specify the maximum size. Let's say for buffer overflow, you set a fixed size for around like 50 characters. You set a fixed size for 50 characters, like your username can carry 50 characters at a time, right? So let's say your password can carry up to 30 characters, up to 20 characters, but you are just fixed a specific size for that variable. That was the basic size for your variable, right? So if I just go with the basic structure for the stack first, I will explain the stack-based buffer overflow. We have another type. We call it simple heap-based buffer overflow. Stack-based is the easier one. So I will explain the stack-based. If you want to learn about the heap-based, you can just go and search on the Google for different heap-based buffer overflow. But again, both the things were somewhat related. The flooding part, the basic simple techniques you have to follow are similar. But the only difference is the memory structure. In general, simple stack-based buffer overflow, on the top, you have a space which was reserved for your variable. In that specific space, you store the value for that variable. Let's say when your application is waiting for the user input, when your application is waiting for the user input for, let's say, username, right? It will reserve a fixed space inside the memory for your specific variable username, right? Let's say for my username variable, right? I'm just writing these terms out there. Let's say this is my space for my username variable, right? And I can take up to 50 characters for my username. This
Parameters.
specific space, you can say, this specific space is generally known as with the register name. This specific space is known as ESP.
Yeah.
ESP. We call it extended stack pointer, right? This specific reserved space for that specific variable is known as the ESP. ESP is the name for the register which points to the specific location, right? ESP is the name for that register which points to this specific location which is used to carry or to which is used to store the username,
Yes.
right? Then after that ESP, we have one more variable just after that. We call it EBP. EBP. We call it extended base pointer. Right? This extended base pointer is used to carry the stack, to carry the address for the base location of that memory. This EBP register is used to carry the base address for that memory, right? So this EBP pointer can contain up to 4 characters. This is the maximum length. This is the maximum length. This is the minimum. This is the maximum. This is the fixed length, you can say. EBP has a fixed length of 4 characters. And one more thing, all these registers store the value, process the value all these registers store the value in form of hex characters, right? So for the conversion, if you want to convert the simple ASCII characters, if you want to convert the message like SONY, right? This is a simple four-word letter. This is a simple alphabet word, right? SONY. We have four alphabets out there. If you want to convert this word SONY into hex, you can use two different formats to represent the hex data. First one is 0x and then your hex data like 00, 01, 02, 03.
Mm.
This one character, single character, is represented with two hex values, right? So if your register can store up to 4 characters, it means for hex data, you will represent it with the 8 hex values, right? You can represent it with this 0x at the beginning, or you can also represent it with /x, 00 /x 01 /x 02, then /x 03, right? You can also represent this hex value in this form. Again, the thing was same, but you can represent the data in this way as well, right? So 4 characters will be represented in form of 8 hex values, right? Other than this, I'm just removing this Sony word right now. All good. After this extended base pointer, we have one more pointer which was generally used to execute the program, to start the program, to process the data. We generally use the specific register. We call it EIP. That again stands for extended instruction pointer. Extended instruction point. We have different name for this specific EIP. You can also call it extended instruction pointer. This is also known as return pointer, or this is also known as initialization pointer. Right? So in the basic normal stack, we have these 3 registers. First one was your ESP, which was used to store the data for your specific variables, right? Second one was your EBP, the base pointer, which is used to store the base value for your memory. Third one was your EIP, which is used to store the memory address for the next instruction my CPU will execute. EIP is used to store the address for the next instruction CPU will execute, right? And our main focus in buffer overflow is to pass our payload, pass our malicious code to this specific EIP without any kind of validation. This is our main objective in the buffer overflow, right? So in the buffer overflow, what you will do, you will simply send, let's say this username can store up to 50 characters, right? What I will do, I will send some 50 characters first, right? First, I will send some 50 characters and I will fill this space. Okay. Maybe we have some space out there. Let me just fix that space first. Yeah, we have some little space out there. So I have to cover up that space. So in normal buffer overflow, what you will do, you will simply send 50 characters to a specific variable username. And when you pass 50 characters, this space reserved for this username, this space reserved for this specific variable will be filled, right? You will completely occupy the space reserved for this specific variable username, right? After consuming that space, if you pass more characters, if you pass more than 50 characters, let's say you pass 52 characters, right? 50 characters will be stored in this specific location ESP, right? Then the 2 characters which were still left, those 2 characters will be used to overwrite this EBP. Not used, you cannot use the term used. Those two characters will directly overwrite the address for this EBP, right? EBP has a static memory location. One more thing, EBP has a static memory location, right? So if you overwrite that EBP, if you send, let's say if you pass some data to the EBP, let's say just by sending some data, I'm able to consume some limited space for that EBP. Let's say I have passed 2 characters to this EBP, right? It can store to 4 characters, and out of these 4, 2 of them will be overwritten by my user input, right? Now the point is your kernel, your simple operating, your simple kernel will never allow a user input to overwrite that EBP. Your kernel will never allow user input to overwrite that base pointer, that specific base pointer, right? So when my kernel will verify that the user input had already overwritten the base pointer, my kernel will simply verify that the address which is contained by the EBP is overwritten by the user input, right? My kernel will simply clean that base address, clean the, you can say, my kernel will simply clean or simply flush the 4 characters, the data stored by this base pointer, and also clean, also flush the data stored in this specific ESP, right? My kernel, you can say when your user input will simply overwrite the EBP pointer, at that time your kernel will automatically flush or automatically clean up the EBP pointer and automatically clean up the ESP pointer, right? When your kernel clean up the ESP and EBP, at that time, when your EIP will ask the EBP for the next instruction, right? Let's say my EIP has an address, my EIP will execute that address, then again come back to the EBP for the next instruction, right? EBP has nothing because EBP was flushed by the kernel. Then it will goes to the ESP and it will ask the ESP for the user input. Again, ESP has no data because again ESP was cleaned, ESP was flushed by the kernel itself again. At that time, EIP will directly point to a valid pointer on the execution. My EIP will point to a valid address for that specific application and execute the user input. Right? When my EIP checks for the data, checks for the valid address inside the base pointer first, then the stack pointer for the user input, and it got nothing. It got nothing from the EBP and the ESP. At that time, EIP will directly goes to a valid any random. EIP will directly goes to any random pointer, right? And wait for the user input and directly execute the user input as an instruction without validation, right? My EIP will directly execute the user input as an instruction without any kind of validation, right? So this is your basic buffer overflow, right? We want to control the EIP. We will just to control the EIP first. We will send the junk so that we can overwrite the EBP. And when we overwrite the EBP, my kernel will automatically clean up the EBP and the ESP. And when my kernel clean up the EBP and ESP, at that time, my EIP will came back to ESP for the instructions, right? And just because EBP has ESP has nothing, then it will automatically execute the user input, right? And in form of user input, at that time we pass our malware, we pass our payload as a user input, right? I know, I understand it seems a little bit complex, but when we perform the practical part, that will better we understand, right? So this is basic buffer off. Let me just write down the steps out there. So your first step, I'm writing all these steps here. So first step will be, right, like your first step would be like spiking the term. Generally, the term is known as spiking, or you can also use the terms fuzzing. In spiking and fuzzing, you are focused on, let's say, in spiking or fuzzing, you want to crash the application, right? In spiking and fuzzing, in this phase, you're focused on crashing that specific application just by sending some random amount of data, some random amount of junk, you can say, right? I will send some junk to the application, right? And if just by sending junk to that application, if I'm able to crash that application, that was my first phase. I'm focused on crashing that application just by sending the junk. It's generally known as spiking or fuzzing. Both the terms were somewhat similar, right? Then the second term was generally known as identify the offset. The second phase, you can see, second step is known as identify the offset. Now, what is offset? Offset is just the sum for your ESP plus your EBP. If you relate it with your current example, you can say like this is the sum for yours. Like in our ESP, we can store up to 50 characters, right? It will be a sum of 50 characters plus in our EBP, we can store up to 4 characters, 50 plus 4, it will be like 54 characters, right? This 54 bytes is your offset. Simple. After that, this is your second step where you're focused on identifying that offset. Again, for identifying the offset, we again send the junk, but in a specific pattern. We will create a specific pattern for our junk and then we will send our junk to identify the offset. Again, it will better be understand when we perform the practical part. Don't worry for that. Then, after identifying the offset, your third phase will be like identify the bad characters. So identify the bad characters. Now, what is bad characters point is? We have some hex characters, we have some hex values, right? We have some hex values which were not, you can say, like which cannot be processed by our application, or which cannot be encoded by our application, which cannot be digested by our application. But the point is, we have some hex character which will interrupt the execution of my application, right? Or which will interrupt the execution of my application again, right? Or it can, or these kind of hex characters can also crash your machine. One more thing, these kind of hex characters can crash your application and can also crash your machines as well, right? So we need to identify those hex values which will interrupt the execution of that application or the execution of that operating system, or which can terminate our operating system, or which can just crash our operating system, right? So we need to identify those characters, those hex values specifically. This is your third step. Now, after identifying those vectors, your fourth step would be identify the pointer, identify the address for this ESP, identify the memory address for this specific location, right? Identify the memory point, right? We need to identify a pointer which points to this specific location ESP, right? We need to find out the pointer which points to this specific location ESP, right? After that, we have the fifth step, and fifth step will be your conclusion. You can say just create a payload, like you can just provide generate a payload and pass it to application, right? And that payload will be executed by our application and your malicious task will be performed on that application. Simple. Don't worry if you're not able to understand these things properly. When we perform these steps, when we perform and write the code, that can be better understand, right? Let's start with these things. So we will code again today. And for the coding part, we need our two machines, our Kali, a little bit again. Second one will be our again any Windows machine, right? So I'll be using my Windows 8 here. You can use Windows 10, Windows 7 again. All were similar. All these were similar, right? You can use any Windows operating system again. So I'll be using a debugger here. This is my immunity debugger, and always execute, always open these debuggers with your admin permission, right? You have to execute, you have to open these debuggers with your admin permission, right? Just run these debuggers as your admin user, and after opening that debugger, you have to attach that specific application, right? You have to attach that specific application which you're going to test for that buffer overflow. Just go with the open option if you want to start that application, and if that application is also already in the running state, at that time you can just go with the attach option. Just go with the attach, and let's go with our application CloudMe, right? And attach the application here. Now, when you attach that application, your debugger will stop. You can see your debugger will pause the execution for that application, which you can see here. Paused state for my application. Now you have to change the state from paused to running, and for that you can just change the state from this button for the run button, or you can just go to this debug tab here and go with the run command, or you can also use the shortcuts for F9, right? Just change the state from paused to running, and now you can verify that the state was changed from running sorry, the state was changed from paused to running. Now when you have that application in your debugger and it's in running state, now you can open your notepad and you can write down some code for that application, right? Let me use the font, and if I can increase the font size here, I'll going with 20 here, or let's go with Korean new. How it looks good. So we will start with our first step, fuzzing, right? For the fuzzing again, I will write some Python code here so we can execute our Python code easily. We have some simple libraries in Python. So again, I'm using a comment out there for the fuzzing part, fuzzing codes, and I'm using one more comment for my again. So let's just don't use this comment out there for the fuzzing. Let's just go with one more comment out there, import library, right? And just import the library with the import command, import system and socket. I'm importing these two libraries here. If you want, you can also import one more library. Like just go with from time import sleep, right? I'm importing the sleep method here, so we can just set a delay. You can set a delay, right? So after that, again, I'm using a variable junk here for my junk again, and I'll pass. You can also pass some characters. You can also pass a single character, or you can also pass some words here, right? But you don't have to pass like 5 words or 10 words or 5 characters or 10 characters, right? You need to start for like 100 words at a time, so you can crash that application, right? So here we have 5 words, like 1, 2, 3, 4, and 5, right? These 5 words will be multiplied by 100, then it will become like 500. It will become like 500 characters, right? They will not remain 100 anymore. They will be 500 characters when you are using some words here, right? Instead of that, you can use a single character as well. Like you can also use A, you can also use X, you can also use Y, you can also use Z again. You can use any character out there. But when you multiply that single character, you can better keep a track for your junk, right? That's why we generally use characters here instead of these words, right? So it's better to use the characters instead of long words, so we can better track our junk size. So I'm starting with 500 again. That will be my junk size. Now, The point is we need to send that junk to our application, right? But when we send our junk as 500 characters, hopefully, let's say my application will not crash. At that time, I have to increment the junk size from 500 to 550, and then I will again send that junk. If you are able to crash, then it's good. Otherwise, we will again increment our junk, then send it again. If you are able to crash this time, that's good again. Otherwise, we will again increment the junk and send it again. So we need to follow these steps multiple times, right? And for that, I'm using a simple loop here. I'm going to loop my commands out there. For that, just go with the while command. Just use the while function here and go with the true. Like execute that function, right? Execute that function all the time. Don't terminate it for any kind of condition. Just keep executing this function, right? Inside this, I'm using a one more function out there. We call it try. Try was generally used to handle the exceptions for that specific application, for that specific program, right? So just we can write our program here inside this try function. Just go with any variable name again. You can again use any variable name. Let's go with variable as well. Again, it's your choice. Which what variable you want to use, right? So I'm using a variable with the name connection, right? Just use any variable name again. It's your choice. After that, here I'm using this variable name to create an object. I will use this variable to call different functions. I will use this variable to call different functions for my different these libraries, these sockets and system libraries. I will use this specific object here, right? So just use a variable name out there and just go with the command socket dot socket and just call the function socket dot af underscore inet. If you are using IPv4 addresses, then you have to use this function af underscore inet. After that, just go with one more function out there, socket dot sock underscore string. This function was generally used when you are focused on establishing a TCP connection. When you want to work with TCP connections, at that time you work with this sock string function. Okay, right? Now we have our object with the name connection, which I'm going to use to establish a connection to use to call different functions inside this socket library, right? So again, just go with the go with the variable name connection dot. I'm calling the function connect here and just go with the variable name. Just go with the IP address. So don't go with the variable name here. Just go with the IP address. So here we have to connect with our application, right? And when that specific application CloudMe, that specific CloudMe application works for my local, just because this application is installed in my this specific machine, right? Just because this specific CloudMe application is installed in my own so, Windows machine, right? So here I will specify my own address as 127.0.0.1. This is the local loopback address, right? For that, I'm using this address just because this application CloudMe is installed in my Windows machine. I'm working right now, right? So after this specific IP address, just go with the port number, and that application CloudMe works with the port number 8888, right? And just complete that function. This line will be used to establish a connection. After establishing a connection, what we have to do? We need to send our junk, right? For that again, call the send function here and just send your junk out there. So simply send my junk to the application. And after sending junk, what we have to do? We need to increment that junk. But before that, let's simply print our junk out there for the actual size. I'm just printing the junk size here, right? Just go with like uh, junk size equals to, just because I'm concatenating with the strings here. So I have to convert my length into string and then I can concatenate here, right? This function len is used to calculate the length for that junk. And just because I have the string data on the left, so we cannot concatenate the string with our integer, which will get calculated by the length function. So for that, we have to convert that integer length into string part, right? And for that conversion, I'm using the str function here. So we can concatenate our string with the string, right? After printing the junk size, now we can just increment the junk. So for that, just go with the junk plus equals to, again, I'm incrementing the junk with character A. I will increase the junk by my 50 A's, right? Or you can also use the same character as Z. Again, you can also use any character. It's again your choice. You can use different characters as well. There is no such limitation. You can use any character. It's your choice, right? After that, when you implement that junk, just call a sleep function so we can set a delay before sending that junk again. Before sending that junk again, we will set a delay for 1 second. That wait for 1 second and then send that junk again, right? Don't send that junk without waiting. Just wait for a second and then send that junk. For that, I'm using the sleep function here. After that, when your try block is complete, then just go with accept block, right? And here I'm using a one more function out there, exception, right? Just call the exception function and store it in my variable name as error, right? This accept is used to catch the errors or to catch the exceptions occurred inside the specific code, right? And I will store that exception which was occurred inside this code. I will store that exception in my variable error here, right? And then simply print that exception, like print it with exception occur, and just go with this one. So you can just separate these things and just concatenate this string. Simple, right? So you can write this kind of specific Python code for your basic fuzzing or different other codes as well, right? And just save this file with a variable with inside a folder. Again, you can also store without any folder. If you don't want to create a folder, then just don't create and store them directly, right? I'm just using a file name like fuzzing.py. So this is a Python code. I will use the extension as py and just save that file, right? Now, when you have the code, you can execute it. And for execution, you can just go with the terminal or you can execute them directly. You can also execute them directly or you can just go with the terminal again. For terminal, just open it. Let me increase the size. Okay, we cannot increase the size if the scroll bar is not working here, not a problem. And zoom was also not working, not a problem. So for the execution, you can directly use like dot slash. Again, you can execute the file like we did in our Linux. You can execute the files in the same manner like we do in our Linux, right? But for that, you have to change the directory. I'm just changing it to documents because all my code was stored inside that specific document folder, right? And just execute the file with dot slash and the file name was fuzzing.py and just press enter. This will send my junk as 500, then 550, 600, 650, and so on. So just wait for the junk to crash your application. And when my junk crash my application, I will simply stop that execution, right? So when we send our junk as like 1150, when I send 1150 times like Z, when I send the junk size as 1150, right? My application crashes, right? But again, this is not the exact offset. This is not the exact offset, right? This is just the fuzzing where you are able to crash that application, right? And if you are not using debuggers here, if you are not using debugger, right, this will easily crash your application. But if you're using debuggers, your application will change its state from running to the paused. If there is any error, any exception inside that application, inside that software, it will change its state from running state to paused state. And this is a clear indication that my application crashes, right? So when your application crash, just close the debugger, start it again with admin permissions again, and start your application. Then again follow the same steps like file, attach your application, and change the state from paused to running. Now the state was changed to the running. Now we need to change our program a little bit this time, right? Our first step is completed where we were able to crash our application, right? For a junk size of around like 1150, we were able to crash our application, crash our software for a junk size of around like 1150, right? That was your first step. The second step was identify the offset. And to identify the offset, you need to create a pattern for a junk, right? You need to create a pattern, a specific pattern for that junk. And for the pattern, you can just go with the Kali Linux and use a tool from Metasploit framework again. Just go with MSF hyphen pattern hyphen underscore create. Just use this specific tool, MSF hyphen pattern underscore create, and just go with the option hyphen L to create a pattern for a fixed size, right? And here you can specify the junk size here, right? So our junk size was like 1150. My application crash is at 1150 characters of junk, right? So just press enter. It will create a pattern for you, right? So just copy this character pattern, just copy this character pattern and send it as your junk, right? So again, I'm just creating a copy for this specific fuzzing.py file and paste it here and just rename it to offset.py. And now let's open it with IDL. We can increase the size from configuration part. Let's just increase it to 20. Okay, now it's better. All right. So just copy that pattern, just copy it from here, copy, and you can paste it out there as your junk. You need to send that pattern as your junk, right? So we don't have to multiply it with any number. Just remove that multiplication number, remove that character Z, right? Because we have our junk, right? And just paste your junk here. We got our junk, and we can also remove this line because we don't want to loop our statements this time, right? We will send our junk at once, and that's all. We will only pass our junk. We are not going to loop our commands, right? For that, just remove these lines. Just remove an indentation as well because Python works with indentation here. So just remove that indentation. And you can also remove some other lines as well because this time we have a fixed junk size, right? So we don't have to print the junk size here. So again, just remove this line which is used to print the junk size. I'm removing this one, and I will also remove the increment which I'm using for incrementation. Just remove this line for the increment, and you can also remove this sleep function as well, right? And just erase these lines. Instead of that, you can use a specific function that was for sys.exit. I'm using the exit function here, right? So just after executing that program for once, just terminate the execution and came back, right? So for the termination, I'm using this function system.exit and just save this file with the same name offset.py, or you can also remove this specific line as well where we were importing the sleep function, right? And just because we were not using the sleep function anymore, you can also remove this line and save. Now we have our specific junk, sorry, we have our junk pattern here, right? And we have a junk pattern for fixed size, one more thing, right? Now we can send that specific junk to our application. My application was attached with the debugger and perfectly running, right? Now we can execute that file just again execute it with the like dot slash. Just copy the file name as offset.py and press enter. This will again send that junk to my application, and again my application was crashed. We can see the state, right? Changed from running to pause. Now here, when we
Sir, excuse me,
yes,
one small
yes,
question
yes.
here. I'm sorry. Now, if you go to this one, Cloud Me, if I run this software, it will be now is a crash. It will give me the message that is not response like this. You mean or what?
If you will not attach that application with the debugger, let's say I'm not using debugger here, and I'm simply opening that application here. It just execute, just open this application. Let's say this was the application, right, without any debugger. And if
Yes.
I crash that application, this will give me the error. But if
Okay.
your application is attached with the debugger, you will not get any kind of errors here, because
Yeah,
that
yeah.
error will be handled. You can say your error
You're
will
right.
be paused by the debugger.
Yes, yes,
Just
yes.
because of just because of that debugger, you will
Yeah,
not get any kind of errors here.
you're right.
And you can also see here, like we got our segmentation fault, like the user input has exceed the limit set for that input part. Your
Okay.
user input has exceed that size
Yeah.
specified for the variable username here,
Sir, I
right?
can do it with any software, with any exe
Not for
software.
not for any exe. This works for like some specific softwares. Like this only works when you are not properly handling the exceptions. Like
Mm.
when we write some code, like if you are writing some code, let's say for Python, right? I have written some code here. I have used these two functions. First one is the try block. So if there was any exception, if there is any error, any problem inside my these few line
Mm.
of codes, these specific 4 lines, if there is
Yes.
any error, that error will be handled by this specific accept code, right?
Mm.
That
Mm.
buffer overflow only works with those softwares where your errors are not properly handled by these kind of accept blocks.
Okay, excellent.
This is not this will not work for all the applications. This will not work for all the applications. This will only work for those applications where your errors are not properly handled, right? So if your application is handling all your errors perfectly, through that you can easily prevent your buffer overflow, right? And if you are using that debugger,
Mm.
you will not get any kind of errors
Yes.
when your application crash. Otherwise, you will get the errors. So now the point is, like when you execute that specific offset.py file, we
Mm.
just attach that application here again. Just attach that cloud me, attach, and change the state from paused to running back. And if I execute that Python file again to send my specific junk pattern,
Yeah.
again it will crash my application.
Goes.
But this time we have one thing. Let's say, like instead of passing 54 characters, if you pass instead of passing 50 characters, because this space is reserved for 50 characters, right? You can only store 50 characters in this space,
Yeah.
right? But let's say if you pass 56 characters, if you pass 56 characters, at that time 50 will be stored inside this specific ESP address, inside this specific memory space, right? This can because this can only store 50 characters. So 50 will be stored here. 4 can be stored by this EBP. So 4 will be stored here, right? And the rest of 2 characters will be stored inside this EIP, right? The rest of the 2 characters will be stored by this EIP. It means your user input will first flood that ESP space, ESP memory space, then it will flood the EBP, then it will also flood my EIP as well, right? It will flood your ESP to your reserved space, it will flood your base pointers address, and it will also flood your EIP, the instruction pointer address as well, right? Because my EIP can also store 4 characters, right? So If you get back to the debugger, you can see my junk was sent to the ESP pointer here. You can verify this thing. We got our ASCII values here, and we can also see that some data will also be sent to my EIP, right? Just because my application crashes somewhere at 1150, right? So you will create a pattern for around like 1200 or like 1300, so that your junk will also flood your EIP pointer, so that your junk will also flood that EIP pointer, right? And we got the same thing here. So just copy that specific data. This is the hex value. This is the hex value for your junk. Again, this is your junk, but your junk is represented in form of your hex data. Again, your EBP pointer, your base pointer, has your junk, but that junk was represented in form of the hex value, right? So you can use any data from this EBP pointer or from the EIP pointer and calculate the offset, right? You will copy that hex values and pass it to your Kali Linux. Let's say you will use a tool here again, just use this specific tool again, but a little bit different. Just go with the offset this time. Your offset, your this specific tool, MSF pattern offset. This will again calculate the junk pattern in the hex value. This will again calculate the junk in form of hex data and verify, or you can say, or match your data here. This will compare your data at the EIP pointer with the data which was calculated by the junk in the hex form. This will convert your junk in form of hex values and then compare it with the EIP pointer, right? So here, just copy this address 316A4230, all right, and just pass it here 316A4230 with that specific option -q, right, where you want to find out the offset. For offset identification, this will again calculate your junk and convert it in your hex form and then compare it, or you can see then try to identify the exact match for this pattern, for this specific hex value, right, and press enter. This will calculate the offset for you, right? When you pass, like when you pass 1052 character of the, when you, like when you pass 1052 character of junk to that application, right, that will flood your ESP and your EBP only, right? Because my offset is the combination for the ESP and the EBP, the base pointer and the stack pointer, right? So after calculating the offset here, after calculating the offset, we got our offset as 1052, right? That was the second step, identify the offset. And when you have the offset, you can switch toward identifying the bad characters, right? So just get back to the Windows machine here and just again restart that application. Just restart the debugger and restart that application. And again, attach your application with the debugger and change the state from paused to running. So now this time we don't need to send our junk anymore. We don't need to send our junk anymore. This time we're gonna send the hex values. We're gonna send the hex values, right? My hex value starts from like /x00. It means my hex value starts from 00 and goes up to FF 02 and 03 and 04 and 05 and so on. It will goes up to /XFF, right? So you can manually write these hex values here, or you can directly search on the Google. You can directly search on the Google for like bad characters. And again, you can follow any link here, and this will give you a list of all the hex characters. It will give you a list of all the hex characters, starting from the specific 00 or 01 sometimes, because 00 is a well-known bad character. 00 is a well-known bad character, right? So you can just exclude it. You can just treat this 00 as a bad character, because for most of the application, for most of the operating system, this 00 can terminate the execution for your application and for your system as well. This is generally known as the null character, right? So you can simply exclude it, or you can just copy some list of bad characters, list of hex values from the GitHub or from any website as well, to pass a list of hex characters. You can say we have our like slash x 01, 02, 03, 04, and we have a list of characters up to FF. Just go ahead, you can see we have the last hex value as FF, right? So here you need to pass all the hex values so you can verify which specific hex value, terminate the execution for that application, right? To identify these things, to identify the hex value which terminate the execution for that application, you need to pass these hex values one by one, right? Or you can also include slash x00 as well, right? And then save this file, or you can say I'm saving this file with a different name this time. Just go with save as, and just go with the file name bad characters.py again, right? So if you just remove that extension again, because we have a Python file already, just save this file. Okay, you need to add the extension. Just go with the right click, rename, and .py. Now it's good. Okay. So we will simply send our hex characters to that application just to check like which hex value is crashing my application, right? So just store all the hex values inside a variable and pass that variable to your application. Right? Pass all the hex values to your application and just send the file. And for sending that bad characters, for sending a list of all the hex values to my application, just attach your application with your debugger and then execute that application, and execute that specific Python code with dot slash bad characters.py name and press enter, right? If that execution, if that execution, you can save the execution for this file bad characters.py, so you can say like when you send these hex values to your application, right? If your application got crashed, if your application crashes, at that time you can say like there is a bad character, there is a bad character inside those, there is a bad character inside this list, right? And to identify that bad character, what you can do, you need to follow, like I need to crash that application just so I can show you. Yeah, like if your application crashes, like when you send the bad character, your application crashes, your application will change its state from running to pause, right? At that time, what you will do, you will just go with that specific register here. You just go with this register ESP, right click here and go with follow in dump, right? When you go with right click and follow in dump, you can see some changes inside this hex table, right? And this will give you a list of all the hex character here. Like if you start from 01, then 02 here, then 03 here, then 04 here, 05 here, 06 here, right? And if there is any bad character in this list, if there is any bad character in this list, right? Two situations happen. Two things can happen. First thing, your system will replace that hex value with a random one. Like we were sending our hex value in a proper sequence. Like we are starting with 00, then 01, then 02, then 03, 04, 05, 06, and so on. Right? We are sending that hex values in a proper pattern. And if there is any bad character, your system will replace that hex value with any random one. Let's say you are starting with 01 here, 01, then 02, then 03, 04, 05, 06. And let's say after 06, you suddenly got like B1. After 06, it should be 07. But instead of 07, we suddenly got B1 here. It means 07 is a bad character, right? It means 07 is a bad character. This is one situation. This is one. Second thing, let's say if after 06, suddenly you got B1 here, then you got B2 here, or let's say you got B1 here, you got then D5 here, then you got E3 here, or after 06, you got random hex values, right? After 06, your pattern is completely like what we call it. I am missing that term again. Your system will completely change that pattern. You can say your system will completely break that sequence, right? So when you got 06 here, it would be 07 here. But instead of 07, you got like B1 here, and then you got D5 here, right? For bad characters, your system can replace that hex value with a random one, or can completely destroy your sequence, right? Second, just because we don't have any bad character for this specific application CloudMe, just because of that, just because there is no such bad character for my application, for my CloudMe application, right? That application will not change its state from running to paused, right? It means we don't have any bad character, right? And if you don't have any bad character, you don't have to exclude them while creating your payload. Because if that bad character is present in your payload, right, your system will be crashed. If that bad character is present in your payload, that can crash your operating system, that can crash your machine, right? Just to prevent that, we have to identify that bad character. So after identifying that bad character, just by sending all the hex values, after identifying the bad characters, right, then you need to identify the memory pointer that points to the specific location, ESP, right? That point to the specific register, ESP, right? And to identify that specific pointer here, just go with the debugger again. Just attach your application. And this time, let me just close this Firefox and attach your application here and change the state from paused to running back. Okay, after changing the state, just get back here at the bottom, right? You need to execute few commands here. And before execution, you need to download some Python scripts. You need to download some Python scripts. Yes. And you can download those scripts from GitHub as well. Just search here for Mona modules, or you can search for Mona master. Just search here for Mona master. Don't go with Facebook, just go with GitHub. Yeah, just go with the GitHub, and you can just follow the repository for like not this one. Okay, just go with like for Len was the actual writer. Okay, search here. Mona. Yeah, just go here for this repository, github.com/corlan/mona, right? All you need is this specific Python script. And for this Python script, you can just download the zip file, or you can just download this Python command again, right? When you download this Python script, just browse these folders, just browse the folder here, local drive C, go with Windows, don't go with Windows, just go with the program files here. Just go with local drive C, then go with program files x86, specifically x86 here, and just go with immunity incorporation here, and then follow this folder. Inside this immunity incorporation, we have one more folder with the name Python commands, right? And just paste that mona.py file here inside this specific directory. C, program files x86, immunity incorporation, immunity debugger, and py commands, right? So after pasting, after like adding that Python command inside this py folder, after addition, just go back to the debugger and execute these commands. Exclamation mona modules. This command mona module will display you a list of all the DLL files, right? It will display you a list of all the DLL files stored in your memory right now, right? This will display you a list of all the DLL files for all the running processes, for all the running softwares you can, right? And here, out of these all DLLs, you need to figure out a specific DLL for that specific software. We were using CloudMe, right? So you need to figure out the DLL files for the cloud. Like this is one of them, and just search here for another CloudMe.dll file. Again, you need to find out all the DLL files for that specific software CloudMe. If you are working on the CloudMe application, then just identify all the
Yeah,
DLL files.
there is one in the middle for
Like this one,
down, 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 down. Yeah, yeah, yeah.
this
Up,
one,
up, up, up.
yeah, this one.
Yes.
Yeah, just figure out all the DLL files for that specific software, right? After identifying the DLL files, after identifying that DLL files, one more thing you need to focus here is focus on that specific DLL file for which you have these two memory protections as false. First one is your safe SEH. These memory protections should be false, right? Safe SEH should be false. ASLR should be false, right? Let's say for that application, for that software, you have like 10 DLL files, right? Out of those 10 DLL files, if there is any DLL file for which you have safe SEH and ASLR as false, right? Then just copy that, then just copy the name for that DLL file. And the name here is qt5core.dll. Just memorize the name for this DLL file. Just keep the name in mind. And that's all. Just keep the name in mind, right? And just modify that command here and just go with exclamation mona and just go with the find -s. -s was generally used to search for something, and find is the command again. Find is the function here. -s is the attribute again. And here I will look for a specific command. I will look for a specific assembly command here. And that command was jump ESP. I will look for a specific assembly command. That command was jump ESP. But your debuggers, so you can see your registers work with the hex codes. Your registers work with hex codes. So you need to convert that assembly command jump ESP into your into your hex value, right? And the hex representation for that command jump ESP will be /x ff/x e4. This is the hex representation for that assembly command jump ESP, right? After that, just go with one more option here. Just go with one more attribute here. Just show with one more variable here, -m. With this -m option, you need to specify the name for the DLL file, right? Because inside the DLL, we have different pointers. Inside all the DLL files, inside a software, we have different DLLs, and inside those DLLs, we have different pointers, right? So this -m will display me a list of all the pointers specifically for this DLL file, not for all the DLL for that specific software, right? This will display me pointers for this specific DLL file, right? Just go with the name here, qt5 core.dll, and press enter. It will display you some pointers for this DLL qt5 core.dll here, and you can see here we got a list of 55 pointers out there, and out of those 55, 20 pointers were listed here, right? So you can pick addresses from these lists. You can pick address from these lists, right? Let's go with the first one. First one was 68A98A7B, and just note down this address anywhere, and let's just note down this address here. So just go with the command, and the address was 68A98A7B, right? This is the address here. One more thing, all these addresses, not only this one, all these addresses here, all these addresses were represented in form of little endian. All these addresses were represented in form of little endian, right? But if you want to pass some address, right, at that time you need to convert it from little endian to big endian, right? Just because this specific address points to this specific ESP, right? We need to send our payload to this specific location, because when my kernel will flush the stack pointer for the base pointer, at that time my EIP will goes to the EBP, and my EBP has nothing. Then it goes to the ESP, the stack pointer, and wait for the input, right? When my EIP is waiting for that input, at that time we will send our payload, right? But to send our payload, we first need to figure out the address for that stack pointer. First, we need to figure out the address for the stack pointer, right? And this was the address for the pointer. This was the address for the pointer which points to this ESP. This is not the address for the ESP. This is just the address for the pointer, which will take me to the ESP, right? You can say this is like a link. This is like a link to my ESP, right? So here we will send our junk. We will send our payload, not the junk. We will send our payload here, right? And before sending our payload to the specific location, we need to pass this specific location with our junk. We need to pass this specific location with our junk, right? So just modify this code a little bit again, and just pass the character is, again you can pass any character, and just go with the offset size as 1052. Then pass your address here. My address will be like 68A98A70. The main point for sending this address, like why I'm sending this address, is because first I will send this address, right? My EIP is waiting for the user input, right? So I will pass a specific address for the EIP, because my EIP can only take input for 4 characters. One more thing, my EIP can take input only for 4 characters. First thing. Second thing, just because my EIP is waiting for the user input here, right? I will send that address to my EIP, and just because that was a valid address, my EIP will goes to that specific address and again wait for the user input. I will send my EIP to the specific address, to this specific address, and then I will send my payload, right? Because if I directly send my payload here, if I directly send my payload here, it can only take an input for 50 characters. This is a fixed size. This was a fixed size, right? We can only send input for 50 characters. So if my payload length is more than 50 characters, it will again simply crash that application and nothing will be executed. My kernel will simply flush that EBP, flush that stack pointer again, and my payload will be flushed by that kernel, right? Just to avoid that thing, I will send my EIP. I will send an address. I will send a valid address to my EIP. Where I will send a valid address to my EIP, and at that specific address, there is no such limitation for the stack pointer. There is no such limitation for the size, right? There is no such limitation for that size. So we at the specific address we can send our payload. So just send your address first and then send your payload, right? So just get here. So this address was represented in form of little endian. So you need to convert the address into big endian form. And for conversion, you can just flip that address to 180 degree, or you can just create a pair of two characters here. Like the last character of last pair was 7b, right? Just go with 7b first, then just create one more pair for two characters. That was 8a. Then just go with 8a again. Then create one more pair. That will be a9. Then go with a9 here. Then create one more pair. That will be 6a. And go with 6a. Right? Just create pair of two hex values and just write down the value at the first, at the end, and the value at the end to the beginning. Right? Just take the last pair and place it at the beginning. Just place the third pair and place it at the number second. Just take the second pair and place it at third position. Just take the first pair and place it at fourth position. This is simple conversion for little endian into big endian.
Yeah.
Right? Now you can use this address, or you can pass this address to your EIP. Just paste this value here with the junk. Right?
Yeah.
Right? So you can just you have to represent this data as hex value, because this was a hex value, right? So you need to represent this data into form of hex data, into form of hex value. And for that representation, you can also use /x. You can just create a pair of two and use /x before these pairs, right? Just to represent, like this is a hex value, right? And this was a hex value again. This is again a hex value, and this is again a hex value. For that representation, I'm using /x. After that, like when you have valid offset size, when you have the valid address, then you can send your payload here, right? Then you can send your payload. If you are working with local buffer overflow, in local buffer overflow, you are aimed in executing some system commands. You are aimed in executing some system commands here. But if you are working with remote buffer overflow, at that time, you are focused on getting a reverse connection. On that time, you are working for a reverse connection if you are working with remote buffer overflow, right? So here, if you're working with local buffer overflow, you can just create a payload through MSF Venom here. Just go with MSF Venom and create a payload for a local command execution. So if you're working with local buffer overflow, but if you're working with remote buffer overflow, just create a payload for a reverse connection, right? One more thing, all that payload, all that payload will be passed in form of hex values, right? So you need to generate the payload in form of hex data, and for that you need to use the format as C. You need to use the format as any language you can say. You can just create the payload in form of like Python code, in form of like C or C++, or in form of Java, in form of like Perl, in form of like Ruby. But you need to create the payload in form of any language, right? One more thing, if you are working with local buffer overflow, then just go with this specific payload, Windows EXEC. This payload was generally used to execute a specific command, right? And to specify the command, you can just use the variable cmd equals to, right? You can again execute some commands here. Those commands will be executed through your cmd. Those commands will be directly executed by your system kernel. You guys, those commands will be directly executed by your system without any verification, without any validation, right? So here I'm just opening a file like mspaint.exe. Like when you execute, when you write this command mspaint.exe in your cmd, it will simply execute mspaint for you. Like I'm just going with mspaint.exe. This will open mspaint for me, right? So again, I'm just executing this basic command through my payload, right? Just go with the format. I'm just using for the language C here. If you have any bad character, then just go with the option -B here and specify all your bad characters. Let's say I have like /x00 as a bad character. I have like /x05 as a bad character. I have like /x f4 as a bad character. So you can specify a list of all the bad characters here, right, with the option -B. But just because for this application CloudMe, we don't have any bad character, so you can just eliminate this thing, eliminate the -B option and just press enter. This will generate the payload for you in form of hex values. So just wait for a second and we got our payload here, but in our hex form, right? So just copy that payload from here and paste it in your code. So again, I'm using one more variable here for my, and I'm using variable name as payload equals to, and paste your payload here, right? One more thing to keep it in mind here, just you can say like just add this line with this one. Only this line of hex values is stored in my variable payload. Only this specific line is stored inside my variable payload here, right? So what you can do, you can just add a word payload plus equals to. You can add these words payload plus equals to before these lines. So just copy this one again and paste it here. Just use these words before. You can use this word at the beginning of these lines, right? So that we can just uh, store all these lines of code, all these line of hex values inside my variable payload here, right? Just because they were just simple string data that will be concatenated easily. Now we have our payload, we have our junk, we have our address. Now you can send your payload, now you can send your junk to flood your stack pointer, to flood your base pointer, so that your kernel will your kernel will flush the base pointer and the stack pointer, right? And your EIP will wait for the user input here at the location of stack pointer again. And here, when my EIP is waiting for that user input, we will pass our memory location, right? And when we pass our memory location, my EIP will go to the specific memory location, and then we pass our payload, right, to be executed. So just add the variable payload here, right? Now my junk will be sent, my specific address will be passed to the EIP, and then my payload will be executed by the EIP, right? And just save all this code inside a file. Again, I'm changing the name here. Just go with like shell code.py and save this file. Right, we got our Python file for all these things for simple execution. Now, when you are executing this shell code, you don't need any debugger. When you are sending your payload, you don't need any debugger, right? So just close that debugger. We don't need it anymore. Just execute your application, just execute your software, just open your software here and execute that Python script, right? For execution again, you can just go with the command like /shellcode.py. And if my code works fine, it will simply flood my application, flood the ESP, flood the base pointer, and then my kernel will flush the base pointer, flush the stack pointer, right, and crash my application. And then
Yes.
it will pass my address to the EIP, the instruction pointer. Then my instruction pointer will go to the specific memory address and wait for my input. And then I will pass my payload. Simple, right? And if everything works fine, my
Enter.
MS Paint will be executed because this specific payload was written to execute the command mspaint.exe inside my terminal. So just execute this payload and we got our MS Paint. My payload is successfully executed. This is your basic local buffer overflow. Remote buffer overflow is nothing different, right? You need to follow these 5 steps again. All these steps were same. The only difference is your payload. The only difference is your payload. When you're working with the remote buffer overflow, at that time, you need to use this kind of payloads here. Just go with the payloads like Windows, simple, let's go with simple shell, reverse, underscore TCP, just go with lhost equals to just specify your IP address as 1.17, specify your port number as 4444. Again, you can use any port number again and create your payload. The only difference is your payload. All other steps are exactly same. All other steps are exactly same. You need to start with the fuzzing, then you can identify the offset, identify the bad character, identify the memory pointer, and then pass your payload to that specific memory location, right? Steps were exactly same. The only difference is your payload, right? When this payload will be executed in the CMD on the command prompt, you will get a reverse connection. Simple. And all we want is a reverse connection for that remote machine. This is your basic buffer overflow. You can just
Sir,
give it a try. Yes.
sir, now you are doing here for the IB to do the buffer flow as a remote area, right?
You can also try it for remote areas, remote application, remote system. Let's say like you are using this kind of software on your on your computer system, on your laptop, like say, right? You are using the software CloudMe
Yeah.
on your laptop. At that time, I can send that junk. I can send that junk for 1052 characters to your application. Then I will send that specific memory address, and then I will send my payload for the reverse connection to your application. I will send this simple. I will simply send this data to your laptop, and your laptop will execute my payload and give me a reverse connection without even touching your device.
Mm.
Just because you are using a vulnerable application, I'm able to execute any arbitrary command on your laptop with these simple payloads.
Okay.
I'm able to execute any command. I can execute any command here.
Okay.
So you can work for local buffer overflow as well. Like if you are working on the same machine, at that time we call it local buffer overflow. But if you are targeting a remote machine, we call it remote buffer overflow. The only difference is this specific payload. The only difference is this specific payload here. One more thing, like when you write the code for a remote buffer overflow, you need to specify the IP address for that remote machine. Don't use this 127.0.0.1 IP address. Just specify the IP address for your remote target machine,
Yeah.
right? And all of the steps work exactly same. Exactly same. There is nothing different,
You're right.
right? Just go with these basic few line of code, and you can just give it a try for buffer overflow.
So we can